Heidi ho, mathletes. Apologize for my absence this morning as I'm at a meeting. I may be back, you never know. Hopefully the quiz went well for you as well. I'd like to start off today by talking about the number pi. And just so you know, pi was discovered, this was not made up. If you took the distance of the diameter and you could bend and stretch it, the diameter would fit 1, 2, 3, and then this little section right here is the 0.14159 of the value of pi. Okay, so technically pi is the circumference or the distance around a circle divided by its diameter. Okay, so if you took any circle, you measured the circumference, and you measure the diameter and you divided them, you would get the number pi. So we're going to need to know two things about an area of a circle. I'd like you to add that this could be pi d. I've heard people say cherry pie's delicious, apple pies are too, to try and remember the two formulas that go with this. But just so we are aware, you have seen this before. This is the reference sheet for Algebra 1, Geometry, and Algebra 2. And right here, you are given the two formulas for a circle. So you don't have to memorize these. You probably will because we use them so much. Okay, but we're going to add to that a little bit because today's lesson is all about finding a portion of the circumference or finding a portion of the area. Okay, so if I had a circle and the diameter was 8, I could find the circumference of it by doing pi times 8. Or since two radiuses are a diameter, I could do 2 times pi times the radius, which is 4. Okay, and we get two types of answers. One answer would be 8 pi. This is called the exact answer. We did the same thing with radicals. If I type 8 pi into my calculator, where is the pi button, by the way? Looking, where is it? Oh, second caret underneath clear. I would approximate this to be 25.1327. So this is called my approximate number, all right? And usually on a test or quiz, they'll say in terms of pi. So this would be the exact answer in terms of pi, or they would say round to, and then this would be my approximate answer. Okay, at the same time, I could find the area of this by doing pi r squared. So 16 pi would be considered my exact answer. That would be how much fills this circle. If I type that in my calculator, where is that pi button again? Oh, second caret underneath clear, got it. I got 50.2654, etc. And this is called my approximate. They would ask me to round to that answer. Okay, so with that said, the first problem is I'm on page 26. And this says that I have a center pivot irrigation system. Basically, it's a sprinkler. The sprinkler goes and then it hits a point, goes and goes back. If you've never played with a sprinkler, then now you know. This wants the area of the section of the field, which is a sector of a circle. Okay, so a sector of a circle is just like if you cut out a piece of it, like a piece of pizza, a piece of pie, something like that. They tell me this is the radius. Okay, so if I found the area of it, I would do 5 or pi times 15 squared, all right? And because I'm not going all the way around it, I have to figure out, okay, how much of the circle is there if I have 120? And a whole circle counts as, uh, shoot, dang it. Oh, 360. So I'm going to take a portion of it by multiplying this by 120 over 360, or it's a third of it, okay? And this didn't say so, but this says to the nearest square meter, so that means I want to type this in my calculator. So I go to my calculator, and if I hit alpha y equals enter, I get the fraction template. 120 out of 360 times pi times 15 squared. And this gives me 235.619,449, and to the nearest meter, this would cover 236 square meters. Okay. The second question says, if the farmer wishes to fence the section of the field, what length of fencing would be needed? Okay, so this would be a perimeter problem, and I know these two straight lengths are both 15. Okay, so I'm adding 15, 15, but now I need this portion of the circumference. Okay, so circumference, we have two formulas. You could use 2 pi r or pi d. That's up to you. Pi d kind of sounds like par d, or some people told me pa d. Whatever, figure it out. So if I did pi times the diameter, I would use 30, or 2 pi times 15 would also give me 30. And again, I need 120 of the 360 degrees of the circle. Okay, so that's really the only thing today is we're going to do a fraction out of 360 times the circumference or times the area. So I would go to my calculator. I add 15 to 15. Alpha y equals enter gives me the fraction template. Okay, and it, if we're using rounding rules, this would round to 61. If I was actually the farmer, I would get 62 meters of fence. About 61.4 rounds to 61 meters. Okay. Now we do have to know that area is square and and if I'm just measuring a length is just meters to the first. Okay, because that's one dimensional. Area is two dimensional. Forgot to pause the video. No big deal. I'm going to skip the arcs one. It's kind of a similar type of question of what we just did. And I'd like to go to the key concept on page 27. So a blank of a circle is a portion of a disk enclosed by two radii and an arc. This is called a sector. So if I have a circle, I have two radii and an arc. That creates this portion of the circle. And the area of the sector is the fractional part of the area of the entire circle. Okay, so I'm going to say the central angle is in n degrees. So how many degrees out of 360 times pi r squared? So pi r squared is on our formula sheet. We need to know the n over 360 part. Now, this is a little confusing. So now we're going to do arc length. We've measured arcs in degrees, but now we need to know how many degrees they are. or how many degrees converts it into like inches, feet, miles, etc. So I'm going to put pi d here. So again, my central angle is n degrees. I do n out of 360 times pi d, or n out of 360 times 2 pi r, which I could keep going with that, but I think that's good enough. So you just have to remember the n over 360 part, you multiply it. Okay, so the main thing is we figure out, do I use circumference or do I use area? This one's the length of the arc. This is a portion of the circumference, so I would use pi d or 2 pi r. All right, they're telling me in the picture 11 is my radius. That makes my diameter 22. And I'm trying to figure out how many feet go around the circle from there to there. Okay, so the newest thing is that 315 is my n. So I'm going to use n out of 360 times pi d. My n is 315 out of 360 times pi times my diameter is 22. Okay, this one says to the nearest tenth, so I will multiply in my calculator. Alpha y equals enter, 315 out of 360 times pi times 22. And 60.47 to the nearest tenth. 10 has 1 0, so the 7 rounds us to 60.5 feet. Okay, not feet squared, because we're doing a linear length, okay, one line length, to figure that out. And we're still on page 27. This is the other type of problem we're going to be asked. Okay, they want the area of the sector. So now we're going to use pi r squared. They want to figure out how much would fill that up. So 10 is my radius, 60 is my n value. This one wants me to leave it in terms of pi. So I'm going to show you how to do that in the calculator. But I've got 60 out of 360 times pi r squared. Okay, and if I want to leave it in terms of pi, I'm going to have some number pi. Okay, and in this case, it's going to be inches squared because it's two-dimensional. And when I do that, I type everything in my calculator except the pi. So I get 60 out of 360. And I'm not going to do pi. Okay, I'm just going to multiply it by the radius squared. Okay, so this gives me 50 over 3. So 50 over 3. They might write it as 50 pi over 3. If you were looking to write it as a decimal, you could write it as 16.6 repeating pi. Okay? So that's really the gist of it. The only thing that gets more difficult is if they want you to do a shaded region. All right, so I'm going to highlight the ones that I know we're going to cover on the test. So I want you to go to page 28. Number 3. Okay, this kind of looks like a candy corn. You got the white part at the top, and then you have the, I don't know, orange part at the bottom. All right, they give me some measurements in here. They tell me OA or AO is 10. That 10 would help me figure out the area of this sector or the portion of that arc. Okay, they tell me that OB is 16. So O to B is 16. And that helps me with that portion of a circle to find the area or the arc length. So this one wants the shaded area. So what I'm going to do is I'm going to start with the area of the larger sector. I'm going to subtract the area of the smaller sector. Okay, so I'm going to do this twice. If I'm doing either of them, like both of them have a central angle of 95. All right, so I'm using pi r squared because it's area. For the larger one, I would do 95 over 360 times pi r squared. My radius is 16. And then for the smaller one, I would again do 95 out of 360 pi times 10 squared. Okay, and I can type all of that in. If you notice that both of them have the 95 over 360 pi, like you literally could do this. All right, but either way, I would like you to pause the video, type this in, and round it to the nearest hundredth. Did you pause it and type it in? Have you touched your calculator yet? Would you mind doing that, please, and thank you. Okay, so I typed it in both ways, 129.3288976, and in the nearest hundredth, 100 has two zeros, so I rounded two decimal places, 129.33. Now, unless they ask you to have units, you don't have to have units. If I did, it has to be squared because I'm talking about an area. So 129.33 centimeters squared. And you should expect to see this on our next quiz and test. The last problem that I'd like to go over with you today is on page 30. And this came off of a Regents exam. I don't know if you can tell with the font, etc. Okay, but this is different because they're going to make us go backwards. The area of the shaded sector is 12 pi inches squared. So in here, if I filled that, it's 12 pi inches squared. Okay, they tell me the length of OA or AO is 6. That's my radius. And they want my central angle AOC. Okay, so this is my N, which I don't know right now. So if I'm kind of following the pattern, I get N over 360 times pi r squared. Because it's area, I use pi r squared. This tells me the area of the sector. So now 12 pi is the area of the sector. I don't know the N over 360. And then I do know that my radius is 6. Okay, so how would we solve this algebraically is kind of the issue, all right? We should not be adding or subtracting anything to any sides. Why not? Well, I'm not going to add or subtract because these are all multiplied together. Times, 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 okay? So if I divide things off, for example, I could divide a pi off of each side. I could divide the 36. And if you wanted, you could leave it like 12 over 36 equals n over 360. Now you have a proportion to solve. 36n, help me with 12 times 360. Anyone? Anyone? Bueller? And I divide that by 36. And my central angle is 120 degrees. Okay, so hopefully I come back by the end of class from this meeting. If not, I should have my after school availability up there. Please come in, especially if you need to make up a test, correct a test, anything like that. And I hope you enjoyed this video. Hopefully the audio quality's there. Stock money out.